Scientists and engineers, Miss Bobby here. We've been doing a lot of talking about energy and energy transfer, and you've learned that temperature is a measure of thermal energy in matter, whether that's a solid, a liquid, or a gas. Today we're going to do an experiment, and so it's question, test, report. Our question is, what will happen to food coloring when it is dropped in water of different temperatures? Will we be able to see a difference? There are a couple of hypotheses we might have for our question. The first hypothesis is that it'll all look the same. It's not going to matter what the temperature of the water is, whether it's ice cold, room temperature, or boiling water. Remember, temperature is a measure of thermal energy. The second hypothesis, or the alternative hypothesis, as scientists sometimes call it, is that, yes, there will be a difference in how the food coloring acts in the 3 jars of water, that it won't be the same. Let's find out which hypothesis is correct. Maybe you can predict what's going to happen. Then, of course, we have to write the report, so we'll be able to write that together. This should be kind of fun. I'm looking forward to it.
Okay, so here we go, scientists. You can see I have a container of cold water over here. This is room temperature water, and this is hot water. Put a little boiling water from the stove. So let's see what happens. Wow. You can tell already there's a difference. Oh my gosh. Look how quickly the food coloring in the hot container is dispersing. We know that when we measure temperature, that tells us how much energy there is, how much thermal energy there is. So clearly there's a lot more thermal energy in this. So that must mean that those molecules are bouncing around and moving, and so it's dispersing this already. Here we are in the room temperature. Well, actually there is some dispersing happening. There's obviously some energy in there that we measured. That's the room temperature, which I'm guessing in the house today is probably 70 degrees Fahrenheit. This one is probably closer to 150 degrees Fahrenheit because I was boiling. And this one, oh my gosh, look what happened. This water was almost ice cold, and so when I dropped in that drop of food coloring, it went right to the bottom. And now you can see, looking at the bottom, it's beginning to disperse or be dispensed. So we know that this particular container with the cold temperature has the least amount of thermal energy. So that means that the molecules are kind of floating around kind of gently and sort of moving, but don't have a lot of energy. And we know this one is room temperature. So, you can see there is some, it is starting to move. So they're moving a little quickly. And oh my gosh, we've only been doing this experiment for 2 minutes and 30 seconds, and already the coloring is completely dispersed in our hot container. So I'm going to turn the video off for a second. Here we go, scientists. Now it's been 5 minutes since I turned off the video, and you can tell that the room temperature jar is beginning to show the movement of the molecules of the dye, and that shows you that there definitely is energy transfer happening between the water molecules in the jar and that drop that used to be at the bottom. It's beginning to disperse. Let's look over here at the cold. It is beginning. You can see some of the dye is beginning to disperse. That means it's being bounced around. As this container gets a little bit warmer, and how much slower it's been in dispersing if you compare the cold jar with the room temperature jar. Hello, scientists. So it's been about 20 minutes since we started this experiment. Look at the room temperature glass or jar and look at the shape that's forming with the dye molecules. Does that remind you of anything? Kind of reminded me of a cloud. There's still a lot of dye down on the bottom, and it's very slowly mixing. Remember when he dropped it in and it went down and it kind of spread out? It still hasn't done anywhere near the same amount of mixing, so that tells you those molecules are moving very slowly in there.
Now see what the jars look like after about 80 minutes. After 160 minutes, all the jars looked the same. So now let's write our report. We learned that the dye molecules disperse the fastest in the hot water. This shows that hot water has more thermal energy than room temperature and much more than cold water. We also learned that the dye in the room temperature jar showed convection currents in the water, just like happens in the water cycle. Hello again, scientists and engineers. I hope you enjoyed the demonstration of thermal energy transfer today, and that you'll remember that energy moves from matter with higher thermal energy to matter with lower thermal energy. I hope that you'll remember that thermal energy moves in water by the process of convection. That is different than in solids. I hope you enjoyed the demonstration, and I look forward to seeing you again. Bye for now.